Okay. All right, here we go. So, guys at home, everybody can hear me and see the board okay? We're all good? Okay, so we are graphing absolute value equations. Right now, the main thing that you guys have probably ever been asked to graph is a straight line, okay? Even if you were graphing a parabola, depending on how far you got in Algebra 1, every single type of equation has what we call a parent equation, a mom and dad, a simplest version ever of that type of equation. It's where all other versions of that equation are made, okay? So the simplest version of a straight line is the line y equals x. It's a straight line who has a slope of 1 and a y-intercept of 0. That would be the parent function to all straight lines. It's the easiest version of a straight line. So the easiest version of an absolute value equation is the equation y equals the absolute value of x. It's the easiest this type of equation will ever be. So we call it the parent. It's the mom and dad. All other graphs are made from some version of this, okay? So to get started, I want to graph the easiest one first, just so you guys can see what the basic shape of the graph is going to be. And then we're going to graph more complicated ones. All right, so because his equation is so easy, we're going to graph it just using good old elementary school. We're going to make a table of values, create some ordered pairs, and blah. All right, so guys, if we plug in -3, what's the absolute value of -3? It's 3. So that means the point -3, 3 is on this equation's graph. All right, let's plug in -2. The absolute value of -2 is 2. So that means the point -2, 2 is on his graph. All right, we're going to keep going. Plug in -1. The absolute value of -1 is 1. So that means the point -1, 1 is on his graph. All right, now we're going to plug in 0. The absolute value of 0 is 0. So 0, 0 is on his graph. All right, plug in 1. The absolute value of 1 is 1. So now 1, 1 is a point on the graph. All right, 2. Absolute value of 2 is 2. 2, 2 is a point on the graph. And then last, because we could do this all day long, guys, we could just keep on plugging numbers in, but we're going to have a pretty good picture to work off of. Plug in 3. The absolute value of 3 is 3. So now the point 3, 3 is on its graph. And you can now see the basic shape of an absolute value graph is going to be a V. Okay? So now, there's two things that a V graph can do. Either the V will open up just like this one did, and it will have a lowest point at the bottom of it, or a V can open down and be upside down and have a highest point at the top of it. So those are what our graphs are going to look like today. Have you guys ever been asked to graph the V's? Yes, no? Everybody else has said no so far. Okay, so these 2 points here, the lowest or the highest point, they're probably the most important point on the graph, and we call it the vertex. Okay, now, on this graph, because his equation was so simple, yes, the shape of his graph was a V that opened up. The vertex is going to be either the lowest or the highest point on that V. Now, because this equation was so simple, his vertex was 0, 0. But guys, it's not always going to be 0, 0 because the equation won't always be this simple. All right? And then let me tell you guys really why his graph is a V. Ultimately, if you take his equation and you remove the bars, guys, it's this. It's the line y equals x, which is a slope of 1 and a y-intercept of 0. A y-intercept of 0, a slope of 1, right? So basically, his graph is the graph of this line, except we took the absolute value. So every single point that had a negative x coordinate, it changed the original y coordinate that was negative to a positive. And it's basically the graph of this line, except every negative y coordinate got bumped up to a positive. And now half the graph is not down here anymore, it got bumped up, and now it's the shape of a V. But that's literally what happens. An absolute value graph is literally taking a line and literally bumping half of it into the positive region because you're taking the absolute value. So since a line has a slope, we can also say that basically these V graphs are going to have a slope as well. But because of that 1/2 that got bumped up, the slope is just a smidge off, all right? But we are going to be able to graph these V's using a slope, except instead of causing, again, I'm going to put it in quotes, it is a slope that we're going to use. It's just a little bit off. So instead of thinking of slope as our normal rise over run number, I'm going to ask you guys to call it this. It's going to be our rise number. We're going to go up or down. But the run number, I want you guys to think of it as an over/back number. Okay, we have a rise number over an over/back number, and I'm telling you, this will make 10 times more sense once you use it in a problem. Okay, so guys, let's sum it all up. The graph of an absolute value equation will be the shape of a V, either opening up or down, and the vertex will either be the lowest point on the graph if the V opens up, right? If it opens up, that vertex will be the lowest point on it, or it will be the highest point on the graph if the V opens down. Okay? All right, perfect. Okay. So what's going to happen is this graph was extremely simple. So a table of values got his graph very, very nicely. However, we're going to be graphing more complicated absolute value equations of this form. So guys, they're going to be sticking numbers inside this problem all over the place. If they put a number in front of the bars, we call that number A. If they put a number in front of X inside the bars, we call that number B. If they add or subtract a number from X inside the bars, we call that number H. And if they add or subtract a number to the outside of the bars at the very end of the problem, we call that number K. So guys, the equations are going to have all these numbers inputted into it, and it's going to make the graph of it much more complicated, okay? So I've given you guys a list of steps to follow in order to create the graph. I'm sure listening to the steps, they're not going to make much sense, but I'm telling you, it's very easy to follow them when we're doing a problem. So let me show you the steps, and then we're going to finally do a problem. Okay. So good. This is what they're going to look like in that form. All right, so when you want to graph them, guys, this is what's going to happen. First, the first thing you're going to want to do is find that vertex, the most important point. To find the vertex, you're going to set whatever is inside the bars, whatever is inside the absolute value bars, the bx minus h part, you're going to set it equal to 0 and solve for x. Whatever number you get for x is the x coordinate of your vertex. All right? The y coordinate of your vertex is probably the easiest part of this entire problem. The y coordinate of your vertex is always whatever number they put in for k. K is always the y coordinate of your vertex. So that's awesome because you never have to work to find your y coordinate. You literally take it right out of the equation. Okay, then you're going to plot your vertex. Once you start getting points, guys, put them right on your graph. Don't wait. Then you're going to use your slope to move to the other points. But first you have to find your slope. To find your slope will always equal this. Well, I told you, the slope is going to be a little bit more complicated than the slope of a line just because of that half that got bumped up. The slope of a V graph will always be equal to A, the number they stuck in front of the bars, times the absolute value of B. whatever number they put in front of x inside the bars. If you multiply that together, it always gets you the slope of your v. All right, and then you're going to use that slope to move to the other points. But remember, I'm asking you guys to think of the slope as rise over instead of run. Think of it as your over slash back number. And again, that's going to make much more sense once you see me do it. All right, then you're going to connect your points and graph your v. All right, guys, let's try it. Let's see what I'm talking about. I don't want to move too fast. Okay. All right, now remember, we are graphing problems like this. All right, just so you can remember who's who. All right, we have to graph y equals the absolute value of x plus 3 plus 2. The first thing we want, guys, is our vertex. Let's get it. Let's get our vertex. To get your vertex, take whatever's inside the bars and set it equal to 0 and solve. So in this case, we're going to take x plus 3, set it equal to 0 and solve. Nice and easy, minus 3. The x coordinate of our vertex is negative 3, okay? Now we need the y coordinate of our vertex. The y coordinate is awesome. It's always equal to k. And k is always the number they added on to the end of this problem on the outside of the bars. So guys, who's k in this problem? 2. So the y coordinate, you literally don't do any work for it. Take them right out of the equation. So that makes our vertex the point negative 3, 2. So go left 3 and up 2, and we already know who our vertex is. Okay, now we're going to use our slope to move to the other points on this V. But first we have to find out who our slope is. Our slope is always equal to A, the number they put in front of the bars, times the absolute value of B. And B is always the number in front of X inside the bars. All right, well, guys, in this problem, what number do you have to assume is in front of these absolute value bars? 1, right? We always assume 1 is in front of something, right? So we know A is 1, and then we're going to times it with the absolute value of B. Well, guys, B is the number in front of X inside the bars. So what number do you have to assume is in front of X inside the bars? Like normal, who do we assume is in front of X when nothing is there? 1. So the slope is going to be the absolute value of 1, which is 1, times 1, which is 1. So the slope is 1. And again, since we want slope to be a fraction, make it a fraction by putting a 1 under it. Okay, here we go. Now, guys, we're going to call this our rise and our over slash back number. So from your vertex, we're going to rise up 1, and then we're going to go over to the right 1. Up 1, over to the right 1. Up 1, over to the right 1. And you can do this for literally as long as you want to. All right, then go back to your vertex. Now we're going to go up 1, back 1. Up 1, back 1. Up 1, back 1. And now you can see that perfectly symmetrical V is formed. And you're done. Okay? Now, remember, a V is symmetrical. I should be able to fold this in half, and everything on either side of the vertex matches. So you should always have these matching points on both sides of your vertex because there is symmetry going on, okay? How does that feel, okay? Everybody at home, that feel okay? All right, now, I just want to give you a clue. This A value, this number in front of your bars, in this problem we said A was 1. That A value will tell you whether or not your V is meant to open up or whether your V is meant to open down. If A is a positive number, your V is going to open up. If A is a negative number, your V is going to open down. So that's always a good thing to check. Did your V go in the correct direction? Because you can catch your own mistakes that way. Since A was positive, the V should have opened up, and it did. All right, since A is a positive number, the V had to go up. All right, let's try another one, because again, even if it feels a little weird, the more you do, it gets easier and easier.
I wasn't here.
Yeah, I did.
But this is new.
Yeah.
You never totally.
Yeah, I didn't like making the table.
Yeah, no, I didn't either. I think it was
So much easier. It comes together much quicker.
Oh my
And I was
God.
finding so many students were making trouble. They were plugging into the chart row,
Yeah.
and it was just not.
Oh,
It was,
yeah.
it was getting too messy.
This is awesome.
So yeah.
That's why I'm like, wait a minute.
Yeah.
Like, how did I miss this? Like,
I
was like, oh,
had
yeah,
to
maybe.
yeah, exactly. I had to simplify it because the chart, like I said, they were plugging into the problem and not getting it right.
No, this is so good.
All right, so here we go. Let's try this one, all right? Now we have to graph y equals the absolute value of negative 2x minus 4. So first things first, let's get ourselves that vertex. Okay, to get the x coordinate, take whatever's inside the bars, set it equal to 0 and solve for x. All right, so all I gotta do is divide both sides by negative 2. And x equals 0. So we know the x coordinate of our vertex is 0. All right, now to get the y coordinate. It's the best part of the problem. Y is always equal to k, and k is always that number that they added to the very end of the problem. So guys, what's k in this problem? Negative 4. All right, that means that your vertex is the point 0, negative 4. Put it right on your graph. 0, negative 4. Okay, now we're going to use our slope to move to the other points, but first we have to find slope. So m is always equal to a times the absolute value of b. So m will equal, well, who's a in this problem if a is the number in front of the bars? Guys, again, what number do you have to assume is in front of those bars? 1. It's not always going to be 1, it's just in the beginning when it's easy, it's 1 a lot. All right, times the absolute value of b. B is always the number in front of x inside the bars. So who's b this time? Negative 2. All right, so the slope will be, guys, who's the absolute value of negative 2? 2 times 1 is 2. The slope is 2. And then since we want it to be a fraction, throw it over 1. So there's your slope. That's your rise and your over slash back number, right? So quick. All right, now, again, just to give you a hint, the a value, which we already said, was positive 1. Since a is positive, we know the v should go up. So we already have a visual as to what this v should look like. All right, so from your vertex, this is your rise, this is your over slash back button number. All right, so we're going to rise up to, over 1, up to, over 1, up to, over 1. And again, do that for as long as you want. Then we're going to go back to the vertex. We're going to go up 2, but we're not going to go over. We're going to go back 1 this time. Up 2, back 1. Up 2, back 1. And then there is your V. Everybody feel okay? Yeah? Guys at home, are you okay? All right, we're going to do one more, and then we're going to call it a day, okay? All right, so let's graph this one. This one says to graph f of x equals the absolute value of x minus 2. Now, guys, if you're one of those people that are looking at this problem like, God damn, that f of x is back, if you don't like function notation, you can always cross it out and put a y in its place and say that it's y equals the absolute value of x minus 2 and turn it back into an equation if you don't like functions. All right, let's get that vertex. All right, to get the vertex, take whatever's inside the bars, set it equal to 0, and solve for x. All right, so I'm going to add 2, and I find out that my x coordinate is good old positive 2. All right, my y coordinate, the best part of the whole problem. Y is always equal to k, which is always that last number on the outside of the problem. Now, guys, remember, we always assume that there's a 1 in front of something when nothing is written. But if they wanted a 1 to be out here, they would have had to have written plus 1. What number do we have to assume is here if nothing is written back there? 0. The y coordinate is 0. All right, so now we know our vertex is the point 2, 0. So put it on your graph. Got it. Now we need our slope. Our slope will always be equal to a times the absolute value of b. So A is always the number in front of the bars, which is 1. And again, it's not always going to be 1. It's just 1 a lot in the beginning. All right, is 1 times the absolute value of B. Who's B? Who's the number in front of X inside the bars? 1. So 1 times the absolute value of 1 is 1. And then if you want to make it a fraction, which we do, throw a 1 under it. So we know our rise number and our over/back number. So from our vertex, we're going to rise 1 over 1, up 1 over 1, up 1 over 1 until I feel like stopping. Then go back to your vertex. You're going to go up 1, back 1, up 1, back 1, up 1, back 1. And there's your beautiful, beautiful V. Okay? How do you guys feel? Pretty good? Okay. Guys at home, can I get a thumbs up if you're okay? Awesome. Okay, so I didn't know how far we'd get today, just with all the beginning stuff that I had to talk about. So I'm going to stop there. We're going to start tomorrow by doing the last 2 problems together, because you finally see slopes that aren't 1 and stuff like that. So we're going to do those 2 problems tomorrow, and then I didn't assign any new homework tonight. So you have no new homework tomorrow. Tomorrow we're going to finish these notes, and I'm going to give you a Google form on about 5 or 6 questions tomorrow, okay? But that's it. No new homework today. All you have to do is finish the 2.8 quizzes assignment if you haven't done that yet. Some of you have already finished that, so then you really do have no homework, okay? If you have any questions, please hang out and let us know. Otherwise, guys, I think we took the attendance. So we are good to go, and you guys can have a great day, and we'll see you tomorrow.